What if all of the satellites circling our Earth suddenly began to fall? Every single one, from tiny CubeSats to massive communication platforms. Right now, you might be looking up at the sky and thinking they're just dots of light. But imagine those dots coming down in a cascade. I'm really talking about a scenario where every satellite in orbit loses its grip, breaks orbit, begins re-entry, and starts hurtling toward the planet. It sounds like science fiction, but let's explore what that would really mean for us, our planet, and our future. First off, what are satellites? They're machines we launch into space that orbit Earth to provide communications, weather data, GPS, scientific observation, and more. Most of them stay up in orbits thousands of kilometers above us in what we call low Earth orbit, LEO, or higher geosynchronous orbits. Under normal conditions, when a satellite reaches end of life, it either gets deorbited and burns up in the atmosphere or moves to a graveyard orbit. And while satellites do occasionally fall back into the atmosphere, the odds of them causing damage on the surface are extremely small. But in this what-if scenario, we break everything. Imagine a chain reaction or a system-wide failure, causing all satellites to lose altitude at once. So now let's set it up. Picture thousands of machines orbiting at high speed, suddenly beginning to descend. They experience intense heat, they start fragmenting, and they begin showering debris into the atmosphere. As they hit the upper atmosphere, many will burn up, but some fragments, especially from larger satellites, could survive the fiery descent. In the short term, skies around the world would light up with streaks of falling metal, electronics, and possibly fuel tanks breaking apart in dramatic re-entries. On the ground, debris could land anywhere: oceans, land, remote regions, perhaps even populated areas. The risk is low for any one person, but multiplied by thousands of objects, the risk becomes noticeable. Air traffic would face major disruption. Falling debris might force flights to change altitude, reroute, or suspend operations in certain airspaces while authorities attempt to track the hazards. Beyond the immediate physical impacts, there's a cascading effect. So many satellites falling would mean loss of GPS, communications, weather forecasting, satellite imagery. Our modern infrastructure would be crippled. Over hours and days, the failure of satellite networks would trigger major societal problems. Navigation for ships and planes would falter. Telecommunication systems would go offline. Power grids that rely on precise timing might suffer. Over weeks and months, the ripple effects expand. Emergency services become less effective, global supply chains suffer, data services fail, and the global economy hits a severe shock. On a longer-term scale, space becomes even more hazardous. The falling satellites create huge clouds of debris in orbit, increasing the risk of collisions, triggering what's known as the Kessler syndrome, a cascade of fragments destroying everything in their path in orbit. That means future satellite launches become dangerous or impossible, and humanity's ability to operate in space could be severely compromised. The environment also pays a price. As satellites burn up, they release materials into the atmosphere. Some research already flags concerns about pollution from satellite re-entries. But here's the twist. Although this scenario sounds catastrophic, it also highlights how resilient and well-designed our systems are today. Space agencies build in deorbit plans, satellites are designed to burn up safely, and tracked re-entries are managed to reduce risk. So the takeaway is twofold. 1. Our dependence on satellites is huge, more than most of us realize. And 2. Even though a complete fall-to-Earth scenario is extremely unlikely, the growing number of satellites and debris means we are moving into a future where space risk is rising. It forces us to think, how well prepared are we for a disruption of that scale? How resilient is our infrastructure? How fast can societies adapt when the tools we take for granted vanish from the sky? In closing, imagine looking up and seeing stars not as points of light, but as pieces of hardware descending. What would you feel? What would you do? That mental image stays with you. If you enjoyed this thought experiment and want more deep dives into big what-ifs for our future, then hit that like button, subscribe to the channel, that's me, Future Quest, and ring the bell so you don't miss the next one. Thanks for watching, and stay curious, because the future is full of extraordinary possibilities.